Calling all skunk enthusiasts. Boy, do we have a surprise for you today. We hope to enlighten you on the chemistry behind a skunk spray. But before we get into that, there are some things about skunks that you need to know. They are only found throughout North and Central America, and nowhere else around the globe. They're quite amazing creatures actually, because they can survive snake bites. They are able to smell and hear very well, but they have very poor eyesight. They are omnivores, which means that they can and will eat anything, from nuts and berries to chipmunks, reptiles, and bees. Baby skunks, especially, are very cute, like a stuffed animal you would like to squeeze. But you better be careful and run away fast, because they can spray up to 10 feet. So, you might have always wondered how these animals spray and why. And it's mainly a defense mechanism to scare off their predators so they don't die. Even the smallest noises can scare them and push them to attack, starting with a handstand. Then they will spray you with their anal glands on both sides. We even have a clip to show you this later in the video, so you know I never lied.
If the skunk isn't shown respect, it ups the ante. Handstanding exaggerates its size and shows off its markings. It's a dance of defiance. Boot stomping drives home the threat. If the message is missed, the skunk reveals its weapon. Like an aerosol, anal glands spray sulfurous chemicals through nozzles aimed at the eyes.
Skunk spray is mostly comprised of organic compounds called thiols. A thiol is an organic functional group that is made up of a sulfur atom with a hydrogen bonded to it. The three main thiols in skunks are E2-butane-1-thiol, 3-methyl-1-butane thiol, and 2-quinoline methane thiol. But there are a couple of other thiols present that differ between different breeds of skunks. Thiols are what give skunks the recognizable odor, and there are a couple of theories about why this is the case. So the first theory is called shape theory, and it functions by way of a lock and key method. If a particle, such as this one, can fit inside of an olfactory receptor, it triggers a response that we recognize as a smell. Many thiols in skunk spray, such as 2-quinoline methane thiol, are very big organic molecules and thus cannot fit into as many receptors. Therefore, some thiols contribute more to the scent than others. The other theory is called vibration theory. Different molecules fit themselves, or different functional groups of theirs, into olfactory receptors, kind of like shape theory, except what triggers the response in this case would be how the molecules or the functional groups vibrate within their receptor. The vibration is directly related to the peaks represented by IR specs in different molecules. For thiols, the SH group, the thiol group, creates a peak in the 2500 to 2700 wave numbers range. And this peak represents the vibration that triggers organisms to perceive the nasty skunk scent.
In addition to thiols, there is a secondary group of compounds that make up a skunk spray. These molecules are called thioacetates. Examining the structures of these molecules, we can see that they do not contain the SH group, and so, as a result, these compounds are not direct contributors to the smell. However, these molecules can be readily converted into thiols. If you or a pet gets sprayed, it is critical that you do not rinse with water, because the conversion is via a hydrolysis reaction, which requires water. Doing so will actually worsen the smell. We can think of this process in a similar way that we think of the hydrolysis of esters. The only difference is, instead of an OR group, we have an SR group. However, it is useful to note that sulfur and oxygen lie adjacent to one another in the periodic table. They are both in group 6A, meaning that they have a similar electronic structure, where they tend to have 2 bonds and 2 lone pairs. As a result, it seems a reasonable conclusion that these two elements undergo similar reaction pathways. So, to see why it is a bad idea to use water to rid of skunk spray, we simply need to redesign the hydrolysis of esters mechanism to fit our thioacetates, replacing all of the O's with S's.
So now I'm going to show you the mechanism by which a thioacetate gets converted into a thiol by a hydrolysis, acid catalyzed. So we're going to start off with your thioacetate. And with the catalyst, you're going to add a proton. And now that the carbonyl is activated, you can add water, a weaker nucleophile, to the carbon. To form this intermediate, and then because we're under acidic conditions, the sulfur can proton hop. And then the leaving group will leave and will regenerate the carbonyl. And then upon regeneration of your catalyst, you end up with the acid and your thiol. And there you have it.
Many of the common recommendations, such as bathing in a tub full of tomato juice, do little more than just make an unpleasant smell. The reason why people think skunk spray and tomato juice cancel each other out is due to something known as olfactory fatigue, which is just another way of saying that your nose gets accustomed to a scent after a period of time. When your nose stops detecting the skunk spray, the strong smell of tomato juice tricks you into thinking that it must have taken care of the problem. However, if another person were to enter the room, he or she wouldn't be easily fooled. The most effective antidotes are those that can neutralize the spray's main ingredients, that is thiols, by changing them into different inodorous compounds. Even though tomatoes have the chemical salicylic acid, which can oxidize thiols, its proportion is so small that we would need huge quantities for this method to be successful. Instead, we look for more efficient ways of getting rid of the smell by making a mixture of 1 quart 3% H2O2, a quarter baking soda, that is sodium bicarbonate, whose combinations serve as the strong oxidizing agents, and 1 teaspoon of liquid soap or dish detergent. This solution is unstable and has to be used as soon as prepared. Let it sit for 5 minutes and rinse thoroughly. Repeat if necessary. The only way to get rid of the odor, as mentioned earlier, is to neutralize the thiols by changing them into compounds that your nose won't recognize as being offensive. So, thiols are neutralized by oxidation into odorless sulfonic acids. Note that in the IR spec of sulfonic acid, the SH peak is no longer present. Using a combination of hydrogen peroxide and baking soda helps with the removal of the odor. Another possibility would be to use vinegar, which has acetic acid in it.
Alright, so now I'm going to show you how to get rid of the skunk smell. And it occurs via the oxidation of these thiols to sulfonic acids. And this is just one of the possible mechanisms by which that occurs. So you start with your thiol, and the electrons on the sulfur will come and pick up this oxygen, localize these electrons on this oxygen. In turn, these electrons will go ahead and deprotonate the sulfur and eliminate a water. Now you have an alcohol, and the process will repeat itself. The sulfur will once again attack the oxygen, the electrons will localize, and these electrons will rip off this proton to eliminate another water. And now you have S double bond O, OH, and the process occurs one last time. So the electrons on the oxygen will localize on the sulfur, kicking these electrons out onto this oxygen, and kicking these electrons out onto this oxygen, creating a hydroxy group. And now the hydroxy group that was just made in the previous step will now deprotonate this H and localize these electrons on this oxygen, eliminating another water. And now you have our product, RSO3H, which is a sulfonic acid and no longer smells.